Hello everyone. On behalf of Team Current Affairs Review, I, Anthony, welcome you all to the discussion. Earth's atmosphere is a distinct feature that makes it unique among all planets in the solar system. The atmosphere, which consists of different layers and variations of gases, has constant interplay with each other, which makes it very dynamic. The atmospheric circulation is dynamically active due to varied factors like thermal circulation, thermal radiation, air pressure, forces like gravity, coriolis, and frictional forces. Due to this changing pattern and uncertainty, they cause disturbances which sometimes become massive and affect a larger area. These atmospheric disturbances are often termed as cyclones and anticyclones. During the last couple of weeks before, we have heard about some atmospheric disturbances, to be specific, cyclones named Ashani in Bay of Bengal and Karim in southern Indian Ocean. But the question arises here, why these cyclonic disturbances occur and what is the mechanism of it. So in today's discussion, we will put emphasis on cyclone and its detailed analysis of it. First of all, before moving further with our discussion, I want to segregate this video into three parts. The first part we will discuss on climatic significance of atmospheric disturbances in both temperate and tropical regions. The second part we will discuss on cyclones and anticyclones, and lastly the nomenclature or simply the naming of the cyclones. So we will move further with our discussion with the climatic significance of atmospheric disturbances. The zones and wind belts, which are often represented as the thermal and dynamic effects of general circulation, give rise to the secondary circulation that creates most obvious weather variations. Here, the general circulation is referred to as the planetary wind circulation, that is trade winds, easterlies, westerlies, jet streams, and secondary circulation are atmospheric phenomena such as monsoon circulation, air mass fronts, upper level vortices, etc. The general circulation can be thought of as a backdrop against which atmospheric disturbances of varied magnitude are superimposed. Aside from the basic characteristics of secondary circulation, the weather in a given location is also influenced by the local occurrences, which are classified as the third order circulation. They can be gravity winds, fall winds, valley or mountain breezes, sea breezes, etc. Now, the most fascinating feature of the second and third order circulation is that they can often mask or cover the overall general circulation, which eventually leads to the formation of atmospheric disturbances. Now, in temperate regions, the atmospheric disturbances play a crucial role in this intricate process of heat transfer between the latitudinal zones. It is very much true that the mid-latitude zones has the most control over these disturbances, and it affects on day-to-day weather. Because of this uncertainty in their arrival timing and frequency, and traveling cyclones and anticyclones cause weather to be highly unpredictable. The precipitation also play a crucial role which get influenced by a variety of atmospheric disturbances that pass through this temperate regions. Now the cyclones act as a convergent wind system in aiding and lifting and cooling the large air mass, which results in precipitation. These cyclones are responsible for large portion of rainfall in various parts of the world. Furthermore, these disturbances influence the transport of humidity from one region of the earth to another. Now, understanding the various magnitudes of these atmospheric disturbances, it allows weather scientists to make predictions about when and where they will occur. Furthermore, storm warnings can be sent ahead of time so that precautionary measures can be taken to save lives and property. Now, in tropical region, the tropical atmosphere can be found between the Tropic of Cancer and Tropic of Capricorn. However, the high pressure cells of the subtropics in both the hemisphere dictate the boundaries of the tropical atmosphere from a meteorological standpoint. Now, it is worth noting that prior to World War II, the tropical weather was thought to be repetitive and uneventful. But when the military planes had to fly through this atmosphere during the war, the idea of the low latitude weather being generally pleasant and uneventful was debunked. Since 1990, a slew of weather satellites include Tyros, Nimbus, ESO, NOVA, and others have been tasked with probing the upper atmosphere. As a result, shocking findings regarding this tropical weather and climate have emerged. The climatologists have only investigated the most violent tropical storms which are found in this region, and they have found that they are in limited numbers, but also they are restricted in limited areas as well. The weak and shallow low pressure system that dominate this humid tropical weather cause the majority of the vast tropical disturbances. When the meteorological phenomena of the tropical and temperate zones are compared or kept in contrary, substantial disparities arises. The tropical region does not experience the same rapid and severe variations in weather as the mid latitudes. It is to be conceived that tropical atmosphere acts as a heat sink for radiant energy, which are emitted by short-wave solar and terrestrial radiations. Our predictions of solar energy depletion due to albedo and cloud cover was significantly in excess of the actual amount. The tropics have a higher rate of energy exchange between the oceans and atmosphere than any other location. Another distinctive feature about this tropical environment is that the precipitation is not distributed randomly, but rather it is concentrated in a variety of small-scale atmospheric disturbances. Now we have come to the second part of the discussion, that we will understand the phenomena. Firstly, the cyclones. The atmospheric disturbances around the low pressure area are responsible for cyclones, which are characterized by rapid and often destructive air circulation. The cyclones are characterized by spiraling winds and low pressure centers. The spiral has a unique direction because the winds blow counterclockwise in the northern hemisphere and clockwise in the southern hemisphere. Now, to begin with, the ocean water must be warmer than a certain temperature, such as 28 degrees centigrade, and the cyclones derive their energy from this heat and moisture in this heated water. Hence, this heat and moisture from the warm waters act as a source of energy for the cyclones. When the cyclones pass over the land or over the colder ocean waters, they quickly dissipate or weaken up due to the lack of heat and moisture supplies. In a tropical cyclone environment, the vertical wind shear is equally crucial. When the wind shear is weak, the cyclonic storms build vertically and latent heat from condensation is released from air directly above the storm, which aids in the development of it. Now, in case of anticyclones, they are commonly thought to be related as the pleasant weather, but this isn't always the same. When cumuliform clouds form within an anticyclone, they deliver heavy rainfall or snowfall under specific circumstances. Sir Francis Galton was the first to use the term anticyclone in 1861. All of the major anticyclones, however, are found in the form of semi-permanent high-pressure cells over the oceans of around 30° north and south latitudes. Now, the cold core and warm core migratory anticyclones, on the other hand, have origin in locations that are farther apart. As a high-pressure system, it blows from clockwise in northern hemisphere and anti-clockwise in southern hemisphere. The most likely reasons for this creation, however, appears to be the radiational cooling of the atmospheric layers, which are close to the snow-covered surface, which are often called as thermal anticyclones. Because of the subsidence within these anticyclones, the atmosphere experiences the subsidence inversion, resulting in the atmospheric stability. Subsequently, the temperature of the air mass involved, the humidity of the air, and the seasons of the year all influence the surface temperature conditions in building up the anticyclone. Anticyclones in the middle latitude always bring the season's coldest temperature, and in summer the heat waves are caused by a stagnant form of heated anticyclone in combination with air from the subtropical and tropical regions. Now we have come to the last part of our discussion, where we will discuss about the nomenclature, or simply the naming of the cyclones. The practice of naming of cyclones, to be precise, tropical cyclones, began years ago to aid in quick identification of storms in warning bulletins, because the names are thought to be far simpler to recall than numbers and technical words. Many people believe that giving storms names make it easier for media to report as well as generate public awareness of warning and improves community preparedness as well. Meteorology later opted to identify storms using the names from an alphabetical list in search for a more structured and efficient naming system. As a result, the storm with a name with letter A, such as Annie, could be the first storm of the year. The forecasters began using masculine names for those developing in the southern hemisphere before the turn of the century. Since 1953, the tropical storms in the Atlantic have been named using this list, which was created by National Hurricane Center. They are now maintained and updated by World Meteorological Organization, which is an international community. Now, it is worth noting that the subtropical cyclones, hurricanes, and typhoons are named after anyone in particular. There are specific guidelines for naming these tropical cyclones. So before choosing, so the names are chosen where the people are of the region are familiar with. Hence, storms are given names so that people can quickly recognize. The proposed name should be politically neutral, as well as from religious beliefs, cultures, and genders as well. The name should be chosen in such a way that it does not offend any group of the people anywhere on the planet. Now, to be precise, in the North Indian Ocean, the area of responsibility is under the Regional Specialized Meteorological Center, RSMC, New Delhi, which covers sea areas of Northern Indian Ocean from the north of equator between 40° east and 100° east. The naming of the tropical cyclones over the North Indian Ocean began in September 2004 by RSMC, New Delhi. The initial name given by O'Neill, which evolved over the Arabian Sea in 30th September to 3rd October 2004. All of the names in the first list, which began effective in September 2004, were used. The second list in the series with 169 names was announced in April 2020 with representatives from all 13 WMO member countries. Recently, the cyclone Asani, which we have heard, was given by Sri Lanka. So this is the end of our discussion. We'll move further with our discussion on next week, where we will discuss about the extratropical cyclone and its structure, mechanism, and theories to it. So that's all for today, guys. Thank you for watching the video. Have a nice day.